Good morning, everyone. So let's continue our class on electricity. I would like you to refer to page number 126 in case you're not understanding something. But right now, let's focus on the video. So look at the circuit below. So as you can see, uh, there's a volt, there's a battery that's giving a particular kind of like it's giving a particular kind of voltage which is denoted by VE, and because of that, there's a current flowing through it. Now, how does the current start flowing? It is when the circuit, when this, when the switch is switched on. Okay. Next comes this symbol here, right here. Okay, let me just highlight it for you a little. Yeah, this symbol here is actually the symbol for, so this symbol, okay, this is the symbol for resistance. So how is resistance denoted? Resistance is equal to V by I. So this symbol, zigzag symbol, is actually denoting resistance. And the Ohm's law, which we studied last time through the videos that I sent you, is actually volt, that is a potential difference upon the current. Okay, this is the Ohm's law. All right. So today's topic is electrical energy. Now, in electrical energy, I want to define it. So, electric energy or electrical energy is the work done for moving a unit charge, which is denoted by the term Q, through a circuit. So, electrical energy is also the same as the work done, W. Okay, we already know. So, let's derive the formula for electrical energy right now. We already know that V, that is potential difference, is equal to the work done upon unit charge, right? So the work done to move this much amount of charge is called the potential difference, okay? So we have, if I isolate W, that is I want only W and I'm given potential difference and the charge, I can write W is equal to V times Q, right? I bring Q to this side and I can see that V times Q gives me the formula for the work done. So I'm going to label it as equation 1 and let's move on and look at the current, electric current formula. So here I have electric current is equal to charge per unit time, right? This I already know. I taught you last time also. We had already told you. So I is equal to Q by T is the formula for electric current. From here I'm going to isolate Q. Okay, so let's take out Q. So Q becomes I, that is electric current, times the time that it takes for the current to pass through the circuit. All right. So look at W. W is the electric energy. So I'm going to put this equation 2, that is Q, charge Q, and I'm going to replace this Q in the work done with I into T. So let's look at how that's done. In equation 1, we see W is equal to V times Q, and then replacing Q by I times T, I get work done is equal to potential difference times current times the time taken. So that gives me, so what was the work done? It was the electrical energy, right? So electrical energy now becomes V times I times T. So that is the basic formula for electric current. Now, based on the Ohm's law, okay, so based on the Ohm's law, suppose I get the formula, I can also include resistance in this formula. So how do I do that? I do that by isolating I and isolating V one by one. What does it mean isolating? Knowing the Ohm's law, I can write V is equal to I times R, taking I this side, and I can write current is equal to V times V upon R. Correct? So here we go. So electric energy becomes V into I into T. That is the same formula above. And now I'm replacing V by R times I. Can you see here? If I take V I isolate, then it becomes I times R. So Ri into, this is V only, है ना? and that becomes into I into T. So we have I into I together. So I times I is I square. You see this? I square. So this becomes energy is equal to I square RT. Similarly, I can get V into I into T, and this time I'm going to remove the I. So here I becomes taken that side in the Ohm's law. I'm going to remove I, isolate I. So I get V by R. So here we have V by R instead of I. And then V and V together. So V multiplied by V becomes V square upon R into T. Okay, so that gives me that these are the three formulas that are used for finding electric energy. So that's all for today. I would like you to solve the question. I would like you to solve the question that is given on page number 148, and this is E part, question 3. So that says obtain an expression for the electric energy consumed in a circuit. So we've already discussed it in this class, so you can go ahead and solve it from the video. Thank you everyone. Have a good day.